So now let's talk about speed of light. Speed of light is a physical constant. Its exact value is 299,792,458 meters per second, or about 186 miles per second. The speed of electromagnetic radiation in vacuum where there are no atoms, molecules that can slow it down. The speed of light does change when it goes from one medium to another, and we will talk about that in the next chapter. Measuring the speed of light has been measured by a number of ways. This sort of shows you one way of measuring the speed of light. It is called the Fizeau's apparatus. We won't go into too much detail about this, but what I want to really talk to you about now is the fact that how do we measure the speed of light? So as we know, light is a wave, right? So if this is a wave, we know that it has high points called crests and it has low points called troughs, right? And the distance between one crest and the next crest is called lambda, or wavelength, right? The number of times a wave repeats itself is called its frequency. Okay? Frequency is given in terms of hertz. Lambda is a wavelength, so this unit is going to be meters. Another important term is called the period, which is given in seconds. It is the time in which you have the relationship between period and frequency is equals to 1 over t. Okay? So, now, how do you find the speed of a wave? Well, it's very simple. What do we know about speed? Speed is equals to distance over time. Yes? Okay. So in this case, if we're talking about a wavelength, its distance unit is lambda. So I'm just going to replace the distance with lambda in meters, because this distance is also measured in meters, and time is measured in seconds. So in this case, the lambda, and I'm going to replace time with period. It makes absolutely no difference, right? Now, once I have this, can I rewrite this as lambda 1 over t? And the answer should be yes. And I know 1 over t is equals to frequency. So a speed of a wave is lambda times its frequency. A supernova is an exploding star. A supernova is billions of times brighter than any ordinary star. Most supernovae occur in distant galaxies and cannot be observed by the naked eye. The last two supernovae visible to the naked eye occurred in 1604 and 1987. Supernova SN 1987 occurred 1.6 times 10 to the 21 meters away from Earth. When did the actual explosion occur? Let's do a quick calculation. What it's saying is, when did this actually occur? I know that formula, right? Speed equals distance over time. So a supernova will be traveling with the speed of light. So I can do delta t equals distance over time. And it gives me, it is 1.6 times 10 to the 21 meters away, divided by the speed of light. So if I do a quick calculation, it comes out to be 5.3 times 10 to the 12 seconds. Now, this looks like a really large number, but in seconds, I mean, I don't know about you, but I find it very hard to think of things when I think about them in seconds. So what I'm going to do is convert them to years to get a better idea. So 5.3 times 10 to the 12 seconds. I want to do it into years, okay? So I know that there are 60 seconds in 1 minute. There are 60 minutes in 1 hour. There are 24 hours in 1 day. And then there are 365 days in 1 year at average. Okay? So this means that if I was to convert this really large number into seconds, I will have to do 1 over 60. Let's see if this works out. So seconds get canceled, minutes get canceled, hours get canceled, days get canceled. Good. So it will be 60 times 24 times 365, and that should give me my answer in years. So I calculate that this number should be 170,123 years. So the supernova that we observed in 1987 actually started or occurred this many years ago, and we only saw it in 1987.